Hey, this is Leach with Simpson Math, and today we're talking about the quadratic formula. So this quadratic formula, it is prerequisite knowledge to college algebra. It's just a quick review video in case you need to brush up on it a little bit. So this is a formula that you need to memorize, but you know me, I'm not a good memorizer. I literally remember this as to the tune of Pop Goes the Weasel. So it's like this. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. So it's that little like Jack in the Box tune. So that's how I literally to this day have a master's in mathematics. That is how I remember the Pop Goes the Weasel. And now forever it is on film. Yay. Okay, so we have this quadratic formula. Use it, cherish it, commit it to memory. So what we do is if I have a quadratic and it is in standard form, so that's the ax squared plus bx plus c, I can grab the a's, b's, and c's, plug them into the formula, and it will work. We will find our roots. Now, it is a good idea for this a to be positive. Not really required, but good idea. So go ahead and, if the leading coefficient is negative, factor out or divide a negative. And then there's a little bit of things, something you don't have to worry about, but it's something we call the discriminant. It's called the discriminant because, well, it discriminates. It puts these polynomials, these quadratics, in their own little spot, in their own little corner. It separates them. It classifies them. It discriminates. So if the discriminant, if this b squared minus 4ac, this what's under the square root, if whatever's under the square root is positive, then we will have two real roots. If it actually equals 0, then we'll have what's called a double root. Those two roots are actually just on top of each other. And if b squared minus 4ac is negative, then we have two what's called complex conjugate roots. We'll have bits of imaginary numbers in with our roots. I'm not requiring you to write this down. It's a good idea to think about. And I like to always do the math, this b squared minus 4ac, in what I call just the discriminant side work, just so that way I can it's just easier for me. I can work faster, and you'll see it when I work through the problems. All right, so let's take a look at solving this equation. X squared minus 12 equals 4x. Well, first, I need to put it in standard form. It's not currently in standard form. So I'm going to subtract the 4 from both sides, and I end up with x squared minus 4x minus 12 equals 0. You can see that I've already ahead and have highlighted the A, the B, and the C. And I have included the positive or negative numbers in front of the positive or negative symbol in front of the 4 and the 12, because that B is a negative 4 and the C is a negative 12. So recall our formula, and we're just going to plug it in. This first step, don't be a math hero. Just plug things in and use parentheses, especially with these negatives. All right, so if I plug it in, I end up with this. I get a negative 4. So notice this. Yes, in a minute that will end up being positive 4. But just for now, this substitution step, write it as this negative 4. Then plus or minus the square root of b squared. Notice I have parentheses around the b. If you don't have parentheses around the b and then square it, that's actually going to be incorrect whenever you have these negatives. So b squared minus, it is always a minus, 4, then a, then c, all over 2a. If you're a color coder and that helps you, do that. I don't continue doing the color coding. After this example, it was just helpful to see it this first time. Few notes. Make sure your square root bar is big enough. Okay, it needs to go all the way to the end of your c. Some students like to put a little tick mark at the end, just so they would know, like they know that they have ended the radical symbol. Secondly, your fraction bar needs to be long. It needs to go all the way to the end of that square root and all the way past the beginning of the negative. Don't have a short fraction bar. All right, let's simplify. So this is going to end up being a 4, and this is going to be a 2. But the messier bit is what's under here. So I like to do what's called just discriminant side work. So just over to the side. So over to the side, I work on my discriminant. So I just copy down my discriminant, and then I square it. So negative 4 squared is positive 16. And then I can multiply these numbers together. Negative 4 times 1 is negative 4. Negative 4 times negative 12 is a positive 48. And you could do the squaring and the multiplying at the same time. I chose to do it in 2 different steps. I think in the next example, I do them at the same time. So I end up with 16 plus 48. And so I end up with 64. Square root of 64 is 8. So since 64 is positive, we have 2 real roots. So I can replace all that square root of negative 4 squared minus 4 times 1 minus 12 with just 8. So now let's simplify this. You're going to do this in 2 different parts, that plus or minus. We would do it once with the plus, once with the minus. So I get 4 minus 8 over 2 and 4 plus 8 over 2. And optionally, you can put it with set notation brackets because these are it's a set of answers. And then let's simplify. 4 minus 8 is negative 4. Divided by 2 gives me my negative 2. And then 4 plus 8 is 12. Divide that by 2 and I get 6. So just to be clear, we have 2 roots, negative 2 and positive 6. And in a quadratic, that's what I'm expecting. Now, admittedly, this particular function could have been solved by factoring. So if you're a little shaky on factoring, and it's a quadratic, you can always use a quadratic formula, but notice this is a lot more work than just factoring. All right, let's take a look at another example. This is 1 over x squared plus 1 over x equals 1/3. You might be thinking to yourself, Mr. Leach, where's the quadratic formula used in this? Well, just wait. So I need to solve for this. Now, admittedly, yes, this is not a polynomial. This is just a prerequisite skill. We're going to be seeing things like this later later in the semester. So I'm just using this time now to cover this. All right, so first, fractions. We hate fractions. I know you hate fractions. I don't want to deal with them. I want to make them go away. So to do this, we're going to multiply everything by the least common denominator. So let's look at our denominators. I have an x plus 2, I have an x, and I have a 3. In terms of factors, is there anything in common with these? Do any of the 3 denominators have anything in common? Do any of them have the same factor? I cannot count the x's. They aren't the same factors, so no. So I'm going to multiply everything by x plus 2, by x, and 3. It looks like this. So everything gets multiplied, and instead of an x times 3, I called it 3x. Everything gets multiplied by 3x times x plus 2. So you get a 3x times x plus 2. You get a 3x times x plus 2. You get a 3x times x plus 2. And I went ahead and put it over 1, so we're clear about that fraction multiplication. When I do, notice the x plus 2 is reduced from the first term, leaving just a 3x. Then just the x is reduced from the second term, leaving a 3 and an x plus 2. And then on the last term on the right side of the equal sign, just the 3's reduce. So we multiplied all values by 3x times x plus 2. When you simplify those terms, so we end up with 3x plus 3 times x plus 2 times x times x plus 2. Again, this is one of those cases when I say don't be a math hero. Just write down what's left over. Then, in this next step, go ahead and do with the distribution. So we distribute the 3, and we distribute the x. All right, now we can add our like terms, and the only thing to add is the 3x plus 3x, and we get 6x. Then I recognize, okay, now I see the quadratic. So now I need to get everything to the same side and set it equal to 0 so I can find these roots. So I'm going to subtract 6x from both sides and subtract the 6 from both sides. When I do, I end up with x squared minus 4x minus 6. And then I can use a quadratic formula and do my substitutions. All right, at this point, I want to do my discriminant side work, because if I do it in this problem, I'm just going to write, it feels like 1,000 lines and be having to rewrite the same stuff over and over. So I just do this discriminant side work. So here, I square the negative 4, and I get 16. And then I multiply negative 4, 1, and negative 6, and get 24. I did do this in 2 separate steps again. You can just do it in one step and jump straight to that. All right, we add them together. I get 16 plus 24 is 40. But this time, 40 is not a perfect square like 64 was in the last example. So we need to think about what perfect square goes into 40, if at all. Well, try 4. So yeah, 4 does go into perfect square. That's the smallest one that could even have an impact is this 4. And here's the tip. If you see an even number, just a random even number, there's a 50% chance that 4 goes into that even number. So 4 does go into 40. That's 4 times 10. And 10 does not have a perfect square. So I can take the square root of the 4, and that's 2, and the 10 just stays inside. And again, from the discriminant, we knew that since 40 was positive, we had 2 real roots. So I'm going to now replace 2 square root of 10 with all of this. All right, so we replace the discriminant with the 2 square root of 10. So we get 2 square root of 10. Here's a tip with this. I want you to think of this as just breaking the fraction apart. So I can say that this is 4 over 2 plus or minus 2 square root of 10 over 2. Just break the fraction apart. Because think about this. If I gave you this and said add the fractions, you should be able to add it and get to that previous line. So if it's possible to go backwards, then I can go the other way as well. So break it apart into its 2 components and then just reduce. 4 over 2 is 2, and the 2 over 10 can reduce. The reason why I want you to just unadd the fraction is it saves you from yourself a little bit. Some of you try to do a little bit extra reductions and stuff, because just for example, if this instead of a 4 would have been a 5, we could not reduce anything. Some of you want to then try to make these 2's go away, but if I just left it as this fraction and this was a 5, I couldn't do anything. But if I broke it apart, I could have had 5 halves plus square root of 10. One more note, square root of 10 over 2, if that's all that I had left, just stays like that. That does not become square root of 5. That's a big no-no. I cannot divide numbers on the outside versus numbers on the inside of square roots. Only the insides can affect each other, and the outsides can affect each other. All right, so just to be clear for our last little bit, there are 2 solutions. I have one that is 2 minus square root of 10, and one that is 2 plus square root of 10. All right, that's your little quick quadratic formula review. You'll see a few of these on the homework for you to work, and it will be showing up here on out in the course. All right, take care, and I'll see you next time.